So two things I would just want to point out before we can kind of finish up this lesson. You might notice like, well, it's kind of weird that for tangent we do pi over k, and here we do 2 pi over k. It seems a little bit different, but those really are the same formulas. And here's what I'd like to remember. So when compressing or stretching vertically, the period, if we want kind of like one formula for it, as it's your normal period for the function divided by k, or maybe divided by b, whatever letter you want to put there. It kind of depends. This lesson's using a different letter, but you can use whatever letter. So my normal period for cosecant and secant is 2 pi. So my formula is 2 pi divided by k. My normal period for tangent and cotangent is just pi. So that's why I do pi over k. My normal period for sine and cosine is 2 pi. So we would do 2 pi divided by k. So let's maybe write that down. So for sine, cosine, let's maybe put commas so it doesn't look like division. Sine, cosine, secant, and cosecant. That means 2 pi divided by k, because 2 pi is the normal. And for tangent and cotangent, that means pi divided by k, because pi is my normal one. And then the last thing that I'll point out, I'll just talk about a little bit more explicitly, is this like double speed and half speed analogy that I kind of talked about a little bit earlier. So if you watch a movie on 2x speed, it's going to take you less time to watch the movie, right? You're watching it twice as fast, so it takes less time to watch, which that would mean if we have a 2x, it's going to take a smaller period. It's going to take a shorter amount of time. Your whole period of your function, whatever it is going to happen a lot faster with like less x distance. Whereas if you watch a movie on half speed, it's gonna take more time to watch it, so your period is going to be longer, right? That took more time to say because it was on half speed. So the period, because the period is the time that it takes for the one cycle to happen, the period is going to be longer. I know it's a little bit weird that when I have like a sine 2x, it actually makes a smaller period, not a bigger one. Or sine 1/2 x, it makes a bigger period, not a smaller one. Right? And the same things happen for secant and cosecant and tangent and cotangent. All the rules are the same. So hopefully this analogy will help out a little bit in trying to conceptualize why the horizontal stretching and compression works the way that it does. All right, that is all I have for you in this objective. Probably the most important thing that I want you to be able to do is I want you to be able to recognize which function is which and be able to identify some general characteristics of them. And again, don't memorize these. Use the facts that we know about how these functions come from sine and cosine in order to get this information to be able to know which graph is which. And I talked about a couple different techniques to be able to do that. And then the other big idea would be able to translate and transform our sine or secant, cosecant, tangent, and cotangent functions. But it's going to work the same way that it did for sine and cosine. So you're going to have really similar things, except instead of having the word sine, you're going to have the word cosecant, for example. And as you're doing your homework on these, always use Desmos to check yourself. Don't get in the habit of using Desmos to get the answer, but use Desmos or some sort of graphing calculator to check yourself. I think it's really helpful to see the words like compressed horizontally by a factor of 2, and also see the nice sketch at the same time and kind of see how those graphs are connected. So definitely be sure to use your graphing calculator as a tool to help you in this, because this is all about graphs.